Now our concept is Lewis acid base concept. In this case, first Lewis acid meaning, which is lone pair acceptor is Lewis acid. Lewis base meaning, which is lone pair donor is Lewis base. Lewis base, lone pair donor. Lewis acid, lone pair acceptor. Who can lone pair can accept generally? Electron deficient molecules. Who have less than 8 electrons, they can accept. And who have vacant orbitals, means once you are writing electronic configuration, still they have some vacant orbitals like p, d orbitals. They may can accept electron pairs. Lone pair donor means they should have extra electrons, means other than bonding electrons. See, we can explain here very clearly. For examples, Lewis acid I am taking here BF3. Its structure is BF3 bonds is there. Each bond have 2 electrons. Then total number of electrons, how many here? 6 electrons. Total number of electrons 6. It is less than 8 electrons, so it is electron deficient compound. It can accept electrons. It is called Lewis acid. You can think about ammonia. It have 2 electrons extra, which is non-bonding electrons. And try to keep in mind, when nitrogen have 3 bonds, it have 1 lone pair of electrons. If oxygen have 2 bonds, it have 2 lone pair of electrons. When halogen is there, it have 1 bond means it have 3 lone pair of electrons. Carbon 4 bonds, no lone pair of electrons. So this is you have to keep in mind. Now it have lone pair of electrons. It can donate easily to someone. So it is Lewis base. Or OH. This is alcohol general structure, but you can see only our concept is oxygen can donate or not. Oxygen have 2 lone pair of electrons, so it can donate easily. And RNH2, it is also have 1 lone pair of electrons, so it can donate. Got it? So these are the Lewis base, Lewis acids. So basically, which is more positive character, that is more Lewis acid compared to these two. This is more positive, more deficiency, more Lewis acidic character. Still we can see which is the Lewis acid, Lewis base, more extension. So we can see here this book. Here these are the somewhat extended Lewis acids. You can see here more electronegative atom and attached to the central atom. So you can see oxygen is more electronegative atom and attaches to sulfur more number of atoms. Here 3 atoms, here 2 atoms. It is more deficiency, so obviously strong acid. And Sn plus 4 plus 2, it is more electron deficiency as well as more Z effect. More positive character means more accepting character. So Lewis acid means electron acceptors. So it is strong acid. Similarly here plus 3 is the more positive character. So obviously strong acid. Next we can see here whenever same positive character is there, lithium, sodium, potassium. Lithium is a small size. It can attract electrons easily compared to potassium. So that is the reason it have more acidic character. And more the positive character, more the Lewis acidic character. And here one note point they mention, all Bronsted bases are also Lewis bases, but all Bronsted acids are not Lewis acids. Its meaning. So Lewis acid meaning lone pair acceptor. Bronsted acid meaning H plus donor. So it is not syncing each other. So what is the neutralization according to Lewis acid base theory? Neutralization is the coordinate covalent bond formation. For example, NH3 is the Lewis base plus BF3, it is Lewis acid. Now we can see it is electron deficient, so lone pair is donating to boron. It is called dative bond or coordinate covalent bond. What we are going to be called dative bond. One atom donating 2 electrons and 2 atoms sharing each other. It is only we call dative bond or coordinate covalent bond. So according to Lewis acid base theory, neutralization meaning, so coordinate covalent bond formation. Got it? So it is the Lewis acid base theory.